Okay, let's take a look at lesson 8.5, slope-intercept form. Slope-intercept form, this is going to be our third way of graphing. So far we've looked at using a t-chart and finding the intercepts as a method. So the third way is going to be using what we learned in the last lesson on slope. So if we want to graph y equals 2x plus 3, one way that we've learned to do it was with a t-chart. So if I just pick a few small values, -1, 0, and 1. So I'm going to substitute -1 in. 2 times -1 plus 3 is going to give me 1. Then I substitute 0 in. 2 times 0 is 0 plus 3 is 3. Then I substitute 1 in. 2 times 1 is 2 plus 3 is 5. So let me go ahead and plot these points, -1, 1, 0, 3, and 1, 5. Okay, so it looks like my line is going to go just like that. Okay, now the second method we learned was using the intercepts. And to use intercepts, you have to have your x and y on the same side. So if this is our equation, we have y equals 2x plus 3. If I subtract 2x on both sides, now I have x and y on the same side. So this is where we did the cover-up method. If I cover up y, putting your finger over it, I get, show you what I get in a different color. I get -2x equals 3. Divide by -2, divide by -2. X is going to equal -3 over 2. So that's my x-intercept, this point. And then if I cover up the y, use purple. If I cover up the x to find the y-intercept, this whole thing goes away, and all I end up with is y equals 3. So my y-intercept is 0, 3. Okay, now if I plot these points, they should fall on the same line because we're using the same equation. We just manipulate it a little differently, and we're using a different method to graph it, but we're not using a different equation, so our points should still follow. So the point -0, 3, oh, there it is, 0, 3, that's my y-intercept. And then the point -3.5, 0. -3.5 is -1.5. And I can tell you from having done this that if you graph this, it will be about 1.5. With the program, it's a little bit off and my line wasn't so straight, but excellent. So we get -3/2, 0 for our x-intercept, and we see that we plotted the same line. So I told you we were going to add our third method on today, which is slope. So what I'd like you to do first is, let's see, it says notice slope m equals in the y-intercept. We learned the other day how to look at a graph and see what the slope is. To do that, we pick 2 points. So I'm going to pick this point and this point. And I'm going to find the slope of these 2 points between these 2 points. So we said slope m is equal to rise over run. Rise has to do with the y, so I'm going to go up 1, 2, 3, 4. So my rise is 4, my run is 1, 2, and both of them are in the positive direction. So my slope, which will go in right there, is 2. Then my y-intercept, we already found actually in the other method, but we could just look at this graph and see that it's crossing right at the y-axis at 0, 3. So my y-intercept is 3. Now what I'd like you to do is take a second and look at the original equation, y equals 2x plus 3, and then what we found here, our slope is 2, our y-intercept is 3, and what do you notice? You're probably saying, oh, they're exactly the same, and you're absolutely right. In every equation, we are going to find that the slope is going to be given to us, as is our y-intercept, and that's what our basis is going to be to go ahead and graph these. Excuse me again. So let's move on down. Good observation if you connected those two. We're going to look at something called slope-intercept form. Slope-intercept form, it says a linear equation, which we've been working with, a straight line, of the form y equals mx plus b is said to be in slope-intercept form. So what I'd like you to do is say this a few times fast, y equals mx plus b, y equals mx plus b, y equals mx plus b, because it's something you're going to want to get stuck in your head. Now we've learned equations in 2 variables. This has 4 of them, so I want to identify what a few of them mean. Every equation is going to have a y and an x in it. Those are not going to be replaced with numbers. But there are going to be 2 things replaced with numbers, and that's our m and our b. M we already know is slope, as we see here. B actually is going to represent our y-intercept. So it's going to represent where our graph, like right here, where it crosses the y-axis. That's represented by the letter B, like Sesame Street. Some people say, why is that? A lot of these variables go back to where the first discovery and invention of the forms kind of came to be many years ago. But another reason, more simpler reason, is that we're already using y, so they can't use y to represent y-intercept. And when you start writing things like y-int in an equation, y equals mx plus, that could get really confusing. So they just canceled it out and said, let's just use a different letter and keep it pretty simple. Y equals mx plus b. Okay, so that's our y-intercept. All right, let's look down here at the example. Notice your y's stay the same. This is the general form. This is our actual equation. The x's are there also. Then we have two special cases. Our m is represented by 3, so in this case my slope is 3. And my b value, the number outside by itself, is represented by 4. So my y-intercept is 4. So the thing you want to recognize is that the slope is always the coefficient of your x value. It's always the number right in front of the x, right in front of it. Then you have this number kind of hanging out by itself. That's your y-intercept. That's your b value. Okay? So let's try example 1. It says identify the slope and y-intercept of the line with the given equation. So we're going to keep that form, slope-intercept form, y equals mx plus b. It helps you write it down a couple of times so that you get it in your head, like I said. The slope is the number right in front of the x. In this case, our coefficient on the x is 1, so my slope is 1, and my y-intercept is -4. The reason it's -4, just so you don't miss that, is don't forget, a minus sign is really plus a negative. So if you need to write that, please do. You don't want to forget that that's a negative. -4. There we go. All right, letter B, y equals -x plus 1. Our slope is -1 because it's a -1 coefficient. Our y-intercept is 1. Good job. Letter C, our slope is 4 because it's a coefficient right in front of the x. Now there is no b, so you could think of it a couple ways. If I put in +0, I didn't change the equation at all. I'm still having y equals 4x because that's essentially not even there. And so I can see, okay, b is just 0. Or if you didn't even want to write anything, you could say it's blank and just put 0 in. Okay, so your y-intercept is 0, which will really be right here, right at the origin. All right, then we get to letter D, and you might think, oh, 3 and then 6. But that's not true. In this case, you have to put it in slope-intercept form, or what we've commonly been calling function form. Okay, so we have to go ahead and get this so that it's y equals 3x minus 2y equals 6. I'm going to subtract 3x. I get -2y, because these cancel, equals -3x plus 6. These aren't like terms, so I can't combine them. Now I'm going to divide by -2 everything. Those cancel out. Y comes down, and I get -3 over -2. The negatives are going to cancel as well. Negative divided by negative is positive. I get 3 over 2x plus -3, because that was 6 divided by -2. So I could have also written -3. So my equation is y equals 3 over 2x minus 3, or plus a negative as I have written here. So my slope is going to be whatever number is right in front of the x, 3 over 2, and my y-intercept is -3. Nicely done, guys. One thing before we move on, this form is called slope-intercept form. We're going to learn next year, actually. You'll learn a couple of other forms, but the easiest way to remember them is look at the equation and see what they're giving you. And what I mean by that is this equation is y equals mx plus b. It should be in your head by now. We've said it so many times. M is our slope, so they're giving us our slope. Check. B is our y-intercept. They're giving us the intercept. And x and y are standard. They're always there. So whenever you think slope-intercept form, well, what equation gives you the slope and the intercept? And there you have it. And I know at this point we've only learned one so far,